In this video, we're talking more about the power property, and in this case, we are using problems that are a little bit more complex within those parentheses. The first thing to recognize when you're working with the power property is it's just like distribution, like the distribution property that you possibly have been introduced to before. This is where when you have parentheses with an expression that includes an addition or subtraction sign with items that cannot be combined, you take whatever's on the outside of those parentheses, if it's sitting right next to it, and multiply it to everything in those parentheses. So in this case, we have multiplication on the inside of the parentheses, but we have to make sure that the exponent on the outside gets distributed to everything on the inside. So the first thing I look for, once I know that I'm using the power property, is to see if there are visible exponents on everything inside the parentheses. So on the first problem here, we have 5y squared. I don't have any exponents that I can see on the 5 or the y, but an invisible exponent is always an exponent of 1. So the first thing I'm going to do is place a 1 on each of those. That reminds me that that 2, the exponent on the outside of the parentheses, has to go to both of those values. So I'm going to go ahead and distribute the 2 to each of those, and remember that the power property says that we multiply our exponents. So I have 5 to the 1 times 2, which is 5 squared, and then we have y to the 1 times 2, which is y squared. Now, I'm going to go ahead and fully simplify this without leaving the base with the number as an exponent. Instead, I'm going to expand and multiply that. So I get 25, because 5 squared is 5 times 5, so 25y squared. Okay, so I'm going to move to the next one to the right, which is parentheses 5xyz cubed. So my entire base is the 5xyz. So I need to make sure to apply that cubed to everything. I don't have any visible exponents on the inside, so I'm going to go ahead and put my 1s here. And then I need to distribute to each of these. It can get a little crowded as we go. Okay, but here we have 5 to the 1 times 3, which is 5 to the 3, x to the 1 times 3, which is x cubed, y to the 1 times 3, which is y cubed, and z to the 1 times 3, which is z cubed. Now again, in this case, I'm going to go ahead and fully simplify out my exponent with a numerical base, which in this case is 5 times 5 times 5, which is 125. So I'm going to rewrite that as 125 x cubed, y cubed, and z cubed. All right, now this next one where we have 3x squared and 3x cubed, I can actually look at this two different ways, but the first thing that catches my eye is that the values inside the parentheses for both of these are identical. And remember that identical bases that are being multiplied together, you can go ahead and use the product property. So I'm going to actually use two different properties to simplify this one. So my base is 3x, so I'm going to go ahead and put my parentheses. The first one has a square, so I have 2, and then remember that the product property says that I add my exponents together, so I need to add my second exponent to that, and I get plus 3. All right, so I'm going to go ahead and simplify that exponent. So I get 3x, still in parentheses, to the 5. Now those parentheses are critical because if you forget to include them, you won't end up applying that exponent to everything. If you dropped the parentheses, you would have 3x raised to the 5, so it would look like this. 3x to the 5, which has the 5 only being applied to the x, and that is not correct. So I'm going to go ahead and cross that off so that we remember that is not what we're working with. And now we have parentheses with an exponent on the outside. So once again, I need to apply the power property. So I get 3 to the 1 times 5, which is 3 to the 5, and x to the 1 times 5, which is x to the 5. And then if you were being asked to fully simplify, you would calculate out that 3 to the 5, and it would be that value times x to the 5th. All right, so this last one, again, the complexity is just slightly higher because notice we have a combination of numbers and variables. The number has no visible exponent, so remember we need to put a 1 there. And then we've got visible exponents on the x and the y. So parentheses with an exponent on the outside, that means we need to use the power property. So I'm going to distribute to each of these, and then do my multiplication. So I get 9 to the 1 times 2. Now I'm going to show one way that you can show your work on this, and I always encourage showing more work, erring on the side of more work than you need than less. So here I'm just showing the actual multiplication step on your exponents, and then I'll go ahead and combine everything. So that was 9 to the 1 times 2, x to the 3 times 2, and y to the 5 times 2. Now I'm going to go ahead and multiply those exponents. So I get 9 squared, x to the 6, and y to the 10. So again, if you're being asked to leave your answer as exponents, you would keep it as 9 squared. If you were being asked to fully simplify, you would do the 9 times 9, which is 81 in this case.